Welcome to Generative Components and Ecosim Building Designer integration. We'll be focusing on the integration between Ecosim Building Designer, Bentley's multidiscipline BIM application, and Generative Components, Bentley's computational design application. In this session, we'll discover just what Generative Components is, how it works as a modeling application, and how it integrates into the Ecosim Building Designer. When we talk about advancing BIM with computational design, our strategy is to strengthen the ties and interoperability between Ecosim Building Designer and Generative Components. When you integrate these two applications together and marry BIM with computational design, you get a powerful tool that helps designers rapidly explore designs, respond to changes faster, model with design freedom, and still deliver information-rich deliverables. So what is computational design? Computational design can be described in a number of ways, such as a method in which design is generated by a set of rules, normally by using a computer program. Most computational design is based on parametric design and is a fast, efficient, and effective method of exploring design possibilities. You can see in the video that GC's ability to apply variations to a design and to visualize the results very quickly, allowing the designer to make more informed decisions. GC is based on relational and dependency models, so it captures relationships between parameters and objects. When you change a design midway through, that change will propagate throughout the model based on the relations and dependencies. What normally would have taken you several days to incorporate one change, now you can do in a few minutes or hours. Computational design automatically propagates changes without the need to manually rebuild the entire model. This reduces a lot of rework for you since it eliminates the need for one-off modeling. So basically, Generative Components enables designers to explore more possibilities in less time and efficiently create, manage, and fabricate complex geometric relationships. It is a great tool for exploring conceptual modeling and refining designs through a number of what-if scenarios. Let's remember, though, that Generative Components is not a new application. Generative Components was one of the first computational design applications. It was started in 1997 as a research project at Bentley Systems. It had its first commercial release in 2007 after 10 years of development involving many beta users. The latest release of GC has many new updates and interface improvements, the most significant of which is the integration with Ecosim Building Designer and the addition of the ABD add-in or BIM nodes. Note that GC can be loaded directly from the Building Designer menu, just as you can load Space Planner or the Structural Workspace or the Mechanical Workspace. The ABD integration means that GC now uses the same project workspace as Building Designer, and it includes the same seed files and datasets. The GC extension for Ecosim Building Designer includes BIM nodes. These are BIM element nodes such as walls, doors, and windows, spaces, slabs, structural members, and even freeforms. These include the selection of a data group catalog item, properties and attributes, family and part attributes, and the default symbology. There are building and floor nodes, allowing you to drive the Building Designer Floor Manager with Generative Components. There is a compound cell factory node, giving you the ability to rapidly create multiple versions of the same compound cell with various sizing parameters, as opposed to making it fully parametric with Parametric Cell Studio. For instance, you might use it to create multiple variations on a curtain wall panel for the Building Designer model. And finally, there are dynamic view nodes for the creation of plans and sections that might need to move their cut plane relative to the model geometry. That brings us to a basic principle. One-off modeling is good, parametric modeling is better, know when to use which. It is great that the integration of GC into Building Designer means that we can create fully parametric and associative models with intelligent attributes. But that doesn't always mean it is always the best solution. Generating a model in GC takes time, typically much more time than generating the same geometry in Ecosim Building Designer. The benefit only comes when many options or what-if scenarios need to be explored, or you need to create and manage and fabricate complex geometric relationships. Therefore, you will most likely select only the most dynamic parts of your building to model in GC, and leave the more static elements for Ecosim Building Designer. Luckily, we have a common DGN file format and a federated approach to the building model. This underground train station is an example of integrating GC and ABD. GC leverages the DGN file format, which is common across the Bentley portfolio, and the interoperability that the Bentley platform provides to collaborate with other users on a team. This model, created in Ecosim Building Designer and GenerativeComponents, takes the concept of an underground train station and includes architectural, structural, and mechanical design. Ecosim Building Designer was used to model the train station, architecture, structure, and mechanical elements, but GenerativeComponents was used to drive the roof geometry. The composite model is used to drive the drawing generation, and the GenerativeComponents model can then be used to drive geometrical setout and fabrication for the roof components. So there are two reasons for using GenerativeComponents to create the roof. First, the roof form required tweaking and changing in order to get the geometry just right. Secondly, the structural members and panels could be created more accurately and efficiently by creating relationships between the geometry and these elements. However, the station architecture consisted of linear walls, doors, escalators, elevators, and handrails. Even though the layout may have changed numerous times, this is fairly easy one-off modeling to do with Ecosim tools, and therefore probably does not warrant the time it would take to model the relationships in GC. The same is true for the structural model of the underground station, and the same is true for the mechanical model. Even the site model is pretty easy to model in Ecosim using solids and surfaces. Each of these models was then referenced together to create the master or composite model, including the roof model that had been modeled in GC. Once the composite model is created, drawings and schedules could be created for the entire building. It does not matter if the geometry and elements were created using Ecosim tools or GC tools. The information on them is the same. They re-symbolize the same, and they populate the same schedules with their information. So that was a basic overview of the GC integration with Ecosim Building Designer. Next, we'll take a look at how modeling in GC differs from modeling in Ecosim Building Designer.